Okay, so hi everyone, Senan this side. In this video, we are going to solve this LeetCode daily problem, which is the strange printer. And yep, it's definitely a hard problem. And to do this, I expect that you know a pretty good amount of dynamic programming. And how are we going to use that? So the question is, there is a strange printer, okay, with two properties or two things that it can do. The printer can only print a sequence of the same character each time. Say you start with A, you can continue printing 3 A's, 4 A's, 5 A's, or 6 A's. And the other way is the printer can print new characters starting from and ending at any place and will cover the original existing character. So either you can print new characters but all the characters be same, or the other thing could be that you can take any two indices of the string and just replace those elements with a different character. So given a string as return the minimum number of turns printer needed it. So one way could be look at this test case before you get all confused. So what I could do is either could print 3A's using this thing, the first one, and then I can print 3B's using this one. So in that case output is 2, but we have another way to do this printing, which is what I can do is print 6A's using this, right? You can print 6A's, and then using this one I can overwrite the last three elements. In both the cases I am getting an output as 2. The other thing is, let's say you have A, B, and A. What you could do, print A using the first one, then print B using the first one, and A using the first one. So that would take you about 3 turns. Another way could be you can print a single A, then you can print two B's, and you can overwrite the last index with okay, but that would again give you an out 3. Since you need to find the minimum, what I could do is find the sequence of all A's to start from starting to end. I print that using the first one and I overwrite this the middle character with now before you get ahead, the question is looking simple but it's not at all simple. It really took a lot of time to think it through, and definitely for a moment I had to see this topics to understand that this is a DP question. So basically what you have to do is what is known as the partition DP, right? And we'll see how we implement that, but I would suggest you to, I told you this is a partition DP and this is a DP problem, and these are the two things you can implement. So how do you this value? So one way could be whenever I find a new element, I just take that. I see 3A's, so I just say that I take a single step and print all 3A's, and then I find another step and print all 3B's. So that would give me 2, right? That's the classic approach, that whenever you see a new character, until the time you are seeing in the contiguous memory location that still have an A or still have the same character, you go on printing it. And since you can print it as many number of times, till the time the characters are same, take a cost of 1 or take a single turn. So let's see how am I implementing. So we have n the size, and I call this helper function with the starting, the ending, and the string s. Now for the time being, forget wherever the DP array is given, because that's just for reducing the time and space complex, basically time complexity, not the space complex, the solution. Now let's look at the printer solution. So what it actually does is, let's first of all look at the signature of so given a string, you have the starting index, you have the ending index, and the string itself. And eventually, since we are using DP, so pass this DP array as well, or you could just pass this by reference as well. But anyways, what I do is, first of all I see if start is greater than end. So that means crossed the limits. So that means I am not actually inside the string. I've traversed the whole string. So in that case I cannot do anything, so I just return 0. Otherwise, let's say if start is equal to end, right? So that means we have a single element. Now the base case is basically if you have a single element, right? So what you do is you just take the value 1 as your answer. There's only a single character, and what you can do is print that single character, right? And that would take you a single turn, and that is what I'm trying to do. Anyways, now what you are seeing is the DP formulation, which is if you have already solved for this start and end index, you just return the answer that you had solved. That's the only use of it. It's not a part of the logic, this solution. That's a part of how you implement dynamic program solution. Now what I do is find an index I such that it actually is differing from the start character. So starting from this I initialize I to 0, then 1, then 2, then 3, and since B is the first point of discrepancy, the point where I don't have the same character as I had in the start, so I take this as my I. So what I'm trying to do here, since I found this I out, right? So now what I'm saying is print this taking one step. This is the one step, and now for the remaining question, just give me the answer using this recursive call, assuming this function is performing correctly. So you get this. If I am just appending new list, I'm appending new elements to the list. What I do is I find the first few elements, the longest sequence of characters or longest substring of characters which have the same as throughout, and I find the index just after that. So while I is less than n, should not go beyond the array, and s of I is equal to s of start. So whatever character I am at, it is equal to the starting index. I just increase my pointer plus plus, and I can just do this as well. It would be also the same thing. For ease of understanding, I'll do it like this. Now I say that assuming I take all of these characters together and I call the function and saying that solve me this portion and get me the answer. So this is what we are going to do. Now I want you to think of this solution recursively, right? I don't want you to go into the depth of this printer function, what would happen, because you assume that this is working fine. Basically the principle of mathematical induction, you assume this is working fine, and for a smaller subproblem you assume for this smaller sub it is working fine, and now you calculate for this subproblem. So that is the whole point of recursion. The next thing would be, let's say if I don't take this, right, and what I would like to do is to replace an element. So this is where we see the partition coming, and this is where you'll get confused. So I say that replace isn't max because I'm trying to replace an element. So in the end, what I'm saying that return the minimum of append and replace. So since append would at least have some non int max value, would not have an int max, so what I do is just, so whenever you return this, you know this int max won't ever be returned, just so you know. Now you start from I and go till the end. Now what I try to do is, so one way is if you just do the append version, this will give you the answer which is incorrect. So since we are replacing, I find this I is currently at 1, right, in this case, and what I do, if start is equal to s of, so that means, so I'm starting from I and going one step ahead until the time, so I plus 1. So if I see a character here after the discrepancy element, and which is same as the start one, right, so what that means is I could hypothetically take this whole thing together and just replace the inner element, right? So that is what I'm trying to do. I'm trying to consider this whole as a part of this function, assuming that you are able to get the value of this. So what I do is, since I need to find the number of ways you can get this value, I say printer of I, j and s. So I is what, the this value, and in this case j is also so j is this, right? So I try to find all the ways to get this value, and that would give me 1, and after that I recursively call for the remaining string that give me the answer for the remaining, and I do this till the time we get the minimum value of replace, and in the end I just, okay, so I would suggest you to go through this. If you want, you can rewind the video and look at this explanation again and again till the time you understand it. That's the whole point. Obviously I don't have my digital pen to write on the screen right now. I hope I was able to do the explanation, and yep, this is working fine. ABA, everything is working fine. Even the solution is accepted, although it's not that great, but it is working, right? The logic since here, because I have used a recursive top-down approach this format, but what you could do is basically write the memoization. This is the memoization. You can write the tabulation version by just taking the base case, and I hope you know how to convert memoization to tabulation. That's what to do. Something, the logic would be similar to matrix chain multiplication. If you've done that, the logic is like that about the memoization to tabulation approach. So yeah, the time complexity is what, since you have states and you are going through a for loop, so the time complexity is n cube and space complexity is n square. So yep, that was the whole video all about, and yep, thanks for watching, and I'll see you in the next video.